All right, so we're going to find the greatest common factor between these numbers here. This trinomial. Is it a trinomial? Yes, it is a trinomial. And I want to factor out all the primes. And one of the easy ways for me to do is to list out the primes, all right? Well, the big prime that I can see right off the bat is I can see 5. All right, so then if I factor out, if I pull out a 5, if I pull out 5 from each of these terms, I can say 5 times, so that's going to give me x to the third, plus 25 divided by 5 will give me 5x squared, plus, and then 45 divided by 5 will give us 9. So I'm going to be plus 9x. All right. So I've pulled out a 5, or I've factored out. I've used the greatest common factor of this. There's no other number that I can factor out of the x cubed. Yeah, I could maybe essentially factor out 5 from x squared, but again, I would have to factor out a 10 in order to pull out an extra 5 from this trinomial. Now, if I notice here, the easiest way for me to talk about this is I have an x here. I have an x cubed there, and I have an x squared there, and I have an x there. So if I were to talk about, remember when we're talking about distribution, if I were to distribute that 5 back into all the terms inside my parentheses, that would give me my trinomial, my original trinomial. So I know that that process is correct, all right? So if I were to pull out, like, well, let's think, what would give us, what would I multiply, take a second and think, what would I multiply by to get 9x? If I have a 9 and an x, 9 times x, because that's 1x, would give me 9x. So I can factor out an x, so I can essentially pull out. So I'm going to rewrite this as 5x. Now remember, that's to the 1 power, so I can kind of say that I'm dividing, okay? If I were to divide this whole thing by x. And if I were to divide this whole thing by x, all right, I'd be subtracting 1 from every term in here, all right? So now 3, I pull out a 3 minus 1 would give me x squared, plus, and then 5, I subtract an x, because x times x will give me, plus 2 will give me x squared. So then that's just going to just leave me with x. And then finally, plus 9. All right. So this is the most simplest way that I can pull out and write this trinomial. And so my GCD is going to be 5x. Now, again, the best way to check to make sure you did your math right is to double check yourself. So I'm going to go back in, I'm going to distribute this 5x to all my terms inside the parentheses. Well, 5x times x squared is going to give me 5x cubed. 5x times 5x is going to give me 25x squared, because we're adding, remember, this is to the power of 1, and this is to the power of 1. So that's going to give me 5x squared. Finally, I'm going to do 5x times 9. So that's going to be 5 times 9 would give me plus 45. X, which, if we look back, I look back at my original greatest common factor. So I had, or my original trinomial. So I have 5x cubed, I have 5x cubed. I have 25x squared, 25x squared. I have 45x, I have 45x. So I did my math correct. I know that my answer is correct, and I am done with that problem. All right, now we're going to talk about factoring out a monomial. Monomial being that I'm going from a quadratic, because this is a second degree. This is a polynomial, so I have 2 terms. And I'm going to factor this out into a monomial. And that means I'm going to have a term that's only going to be by itself. So I'm going to look at this. Again, I'm going to do the same process that I did before. I have a 4 here, and if I were to talk about 4, well, 24 divided by 4 will give me 6. So I can factor out a 4, and then I can rewrite 2x, x squared minus 24 divided by 4 will give me 6x. All right, so if I were to factor out, my greatest common factor of my coefficients would be 4 in these 2 terms. Now, I can factor out another GCD, and that other GCD is going to be an x, because the reason I know it's x, I have an x squared here, and then I have x here to the degree of 1. So that means that I can pull that out. So if I were to say 4x, then this is going to become x minus 6. Because remember, 6 times x will give us 6. So we're just going to write 6 so that when we distribute that back in to double check ourselves, we can make sure that we have our expression in the most simplest terms. And I know that I'm done here because I don't, I have a constant inside my parentheses. And now let's check ourselves. So let's distribute this back. So we're going to distribute our monomial, so it's degree 1 term, and I'm going to distribute that back in. So I'm going to say 4x times x, that's going to give me 4x squared. 4x times negative 6, 6 times 4 gives me 24. So that's going to be minus negative 24x. I'm going to check it back to my original expression. So 4x squared, negative 24x, negative 24x. So that is my check. I'm good. So I am done. Good job. Great job. All right, I will see you in the next video where I will talk about problem number 4. And then lastly, I'll go into some example problem sets.